Hey there, it's Mrs. Marquette, and we again today are going to talk about solving quadratics and about the graphs of quadratics. Remember that we call the graph of a quadratic a parabola, so I'm going to use those two words interchangeably today. And today we're specifically going to talk about using the graphs of quadratics to solve problems. So we saw last class that there are really two major ways to write the equation for a parabola. We have f of x equals ax squared plus bx plus c. And remember that f of x is just another name for y. And then our f of x equals a times x minus h squared plus k. This version is called vertex form. And again, we can still say that f of x is another name for y. So those are the two ways that we see our graphs of parabolas, or our equations for the graphs of parabolas. And today we're going to use these equations to solve problems in this form. 0 equals ax squared plus bx plus c. What you'll notice is really the only difference is that this version equals f of x, or equals y. This version equals 0. So the way that we're going to solve these problems is we are going to see where our parabolas cross the line y equals 0, where our y is equal to 0. Okay. Just a quick little reminder about the graph of y equals 0. The graph of y equals 0 is a horizontal line. So if this is our xy graph, the x-axis, the y-axis, that's the place where every single y value is 0, so it's a horizontal line right on that x-axis. So I'm always going to be drawing that horizontal line at the x-axis. So below we have the function for f of x equals x squared plus 5x minus 6. Remember that this can be a y equals. Based on this graph, how many real solutions does the equation 0 equals x squared plus f of x minus 6 have? So what we're going to do is we're going to draw a line at y equals 0. So that's the line y equals 0, and our goal is really to say how many times do those two graphs intersect. And I can actually circle the two places where that happens. So there are 1, 2 solutions. So my answer there is really just the number 2. What are the solutions of 0 equals x squared plus 5x minus 6? If we zoom in, we can actually see what those 2 points are. So this is the point 1, 0. It crosses right on a grid mark. And on the other side, we have 1, 2, 3, 4, 5, 6. So negative 6, 0. So those are actually our 2 places. It's when x is equal to negative 6 and when x is equal to 1. That's when y is going to equal 0. So these two we can call our solutions to that equation 0 equals x squared plus 5x minus 6. So again, we know what y is equal to. Our y is equal to 0 and 0. So our x values were negative 6 and positive 1. Now, we actually know how to solve these problems already using factoring. So let's go ahead and factor x squared plus 5x minus 6. We have 0 equals x squared plus 5x minus 6. This is an add multiply problem. We get an x and an x. The two numbers that multiply to 6 and add to 5, that's going to be 6 and 1, a positive 6 and a negative 1. But then remember, we have to set each equation equal to 0. Oops. So our final answers really are x equals negative 6 and x equals 1. So our answer is yes, it is equivalent as far as our answers go. This should always be the case. If you have 2 solutions for a quadratic equation, you should get it factoring or by graphing. This is just another tool in our toolbox in order to be able to solve. So recap. Again, this equation y equals x squared plus 5x minus 6 when we set it equal to 0, has two solutions, specifically when x is negative 6 and when x equals 1. On to number 2. Now I'm giving you the graph of f of x equals negative 2x squared. Notice it opens down like a frown because I have that negative out front. And based on the graph, how many real solutions does 0 equal negative 2x squared have? Remember, I'm looking for where is 0, the y value. So let's draw that line. So that's the line y equals 0. How many times do those two graphs cross, the parabola and y equals 0? Well, it looks like it only happens one time, right there at the point 0, comma 0. So if I have one solution, one real solution, and what are the solutions? Well, the x value here is x equals 0. We don't have to write 0, 0 because we already know we're looking for the y value of 0. Really, all I want to know is when does that happen for x? So far we've been able to have two solutions. We've been able to have one solution. There's one more situation. So below is the graph for f of x, or y equals 2/3 x squared plus 4. Based on the graph, how many real solutions does it have? In other words, how many times does my parabola cross the line y equals 0? That's because this number is 0. If that number was a 1, we would draw our line elsewhere, but it's y equals 0. So how many times do those two intersect? Never. So it has 0 real solutions. And what are the real solutions? Not applicable. There aren't any real solutions. They never intersect, so we can say not applicable. And notice that is a possibility. We can have two solutions. We can have one solution. We can have 0 solutions. Remember that there was some times that we couldn't factor expressions. When we can't factor expressions, it's not going to work out to have perfectly rational solutions. Sometimes you don't even have real solutions. So we'll see in a couple days actually when that happens. Now these are the problems you'll actually be dealing with on your homework. So number 4, they say an object is thrown straight up into the air at an initial velocity of 2 feet per second. It is thrown from a height of 6 feet off the ground. Its height h in seconds in feet at t seconds is given by the equation h of t equals negative 2t squared plus 12t plus 6. So all of that beforehand was just getting to this point. This is what I want you to look at. The graph is given below. So what they're saying is, I'm standing here, I'm throwing something in the air. Say, maybe it's a cat. So cat is going up in the air. It's going to go up, 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 and what goes up has to come down. Okay, so we can see that I'm going to hit the ground right here. As far as our axes go, we've got t in seconds. We've also got our height is h in feet. So I'm going to write h and feet. And they want to say find all times t that the object is at 15 feet off the ground. Okay, so that's 15 feet off the ground. We've only so far dealt with when I actually am at 0, or really for us it'd be hitting the ground. But if I want to look at when t hits 15, that happens right here at y equals 15, or h equals 15. Either one of those will be fine. So I want to know when are the two times that that happens. And in order to look at this, I actually want to look at a graphing utility. So if you've got your graphing calculator, that'll work. We can also look at Desmos, the app. Or on a test, you could really go ahead and estimate whatever point that is. But let's go over to Desmos. Okay, so here is my graph. I've got 0, I've got the line 15, and there's my parabola. The points that I'm really caring about are these two. I've got 0.879, comma 15, and 5.121, comma 15. So bring that on over to our graph, and those are the 2 points that we've written. So 0.879, comma 15, this is what we already knew we were looking for. The height is 15. So this is our t-value. Our time is 0.879 seconds. That's the first time we hit 15 feet. That's when the cat is going up. But then when the cat comes down, again I hit 15 when my t-value is 5.121 seconds. So that's letter A. Again, I'm just looking for where that height is 15, so I can find those points actually on my graph, and then you can go and use a graphing utility or estimate. If you would have said like close to 1 second and close to 5 seconds, I would have been okay with that. And B, when does the object hit the ground? This is a little easier for us to deal with. That's going to be the ground is at 0. So when does it happen? Right here. You can see if you zoom in, that looks like it's hitting right exactly at 7, 0. But we can double check using our graph. It looks like it's actually hitting at the point 6.464. And I was actually not on the grid mark exactly, so it's a good thing we checked. So we will say that we're at 6.464 seconds, which makes sense because I've gone up at 0.879 seconds, so almost a second. The cat's in the air. It's come down. It's back at 15 at 5 seconds, and it takes another second to hit the ground. So when you're looking at your homework, this is the kind of thing that you're going to be doing, just interpreting a graph. Usually the word problem is going to give you a situation where something is being thrown or something is being launched, and what you really want to do is figure out your axes. So in this case it was seconds on the x-axis and our feet on the y-axis. Am I looking at a specific height, like in this case, or am I looking at hitting the ground? But that will all depend on what the problem is asking you to do. So go ahead and try those practice problems and let me know if you have questions.